And we're going to look at order of operations. I think most of you are familiar with PEMDAS. The only caveat with PEMDAS is that it does not imply that you do multiplication and division at the same time, at the same level, and addition and subtraction at the same level. So we'll talk about that. But first, because the P in PEMDAS, or sometimes it's a G, GEMDAS or GEMDAS, is a grouping symbol. And so we evaluate all our grouping symbols first. But what is a grouping symbol? Well, parentheses is the one that comes to mind first typically. And there are square brackets, which serve the same function as parentheses. And then absolute value is a grouping symbol. And then how about a fraction bar? We want to evaluate everything in the numerator first with order of operations, and then everything in the denominator together, and then simplify. That's how we would do it using order of operations. We'll see later on that you don't always have to use order of operations. There's a way to apply our properties of numbers to make some shortcuts, but for now it's simplest just to use order of operations. So PEMDAS, remember, is parentheses are grouping symbols, and then next you would evaluate any exponents. And then multiplication and division are at the same level. You evaluate both of them next, but if you have both in an expression, you take them from left to right. So you do, if you have a division to the left of a multiplication, you do it first. Okay, and then similarly, addition and subtraction are the last operations we do, but neither of them comes first. What comes first is the one that's on the left. So you operate from left to right. I hope I explained that well. The examples will help. Okay, so take a look at these examples. Which operation would you do first? Well, multiplication comes before addition or subtraction. So we would turn that 2 times 3 into a 6. And then we have both addition and subtraction, and they're at the same level. Neither of them comes before the other. What comes first is the one that's on the left. So we'd evaluate 18 minus 6, which is 12, and then that equals 17. Okay, what about 10? We want to evaluate what's in the grouping symbol first. So this becomes 16 times 3 plus 5. What's next? Well, multiplication comes before addition. So 16 times 3 is 48. 48 plus 5 is 53. Now I want you to pause and do the you try. Now do bear in mind that when you're evaluating an expression that's within a grouping symbol, the order of operations still apply. Okay, so the order of operations applies to this, so within the grouping symbol, we'd pick the grouping symbol. 3 plus 5 is 8, so this is 2 times 8. And then I have to do what's in the grouping symbol first, 18 minus 16, and this is 2. Hopefully that's what you got as well. All right. Now, writing expressions. I have provided you, and I'd like you to print out, a separate handout that has words that suggest mathematical operation, and it summarizes some of these, what words you can expect to see that imply certain mathematical operations. And it has this little hint on there, because this is a really common mistake people make. The phrase is less than means is less than. You can use this symbol. So if I have 6 is less than 3, I can write 6 is less than 3 as a mathematical expression. Well, 6 is greater than 3 would be a better one. How about 3 is less than 6? So if I have 3 is less than 6, I can write 3 is less than 6 as a mathematical expression. But the phrase less than means subtracted from, so 3 less than 6 means 6 minus 3. So you have to be very careful to read what you're being asked to do very carefully. Okay, I guess that was a little bit redundant. You have to be very careful to read the words, every single word, when you're doing these problems. In the same way, is greater than means greater than, the greater than symbol, and the phrase greater than means added to. So 6 greater than 3 would mean 6 plus 3. All right. Subtraction is not commutative, order matters. And English phrases generally imply the order, although we'll see there are a couple of exceptions down here. We'll take a look at them as we get down there. A fraction of a number means to multiply the fraction by the number. This is not good grammar. By the number. Okay. Translate the following algebraic expressions. So 18 minus a number x, well, that's just 18 minus x. 18 less than a number x, now be careful here, you see less than, you don't want to put a less than symbol. 18 less than a number x is x minus 18. 18 subtracted from x is x minus 18. M less than a number 12. 12 minus m. 2/3 of, now remember, a fraction of a number means to multiply the fraction by the number. So 2/3 n. Now go ahead and pause and you do the you try. Okay, 1/2 of a number h is just 1/2 times h. The sum of 6 and a number w is 6 plus w. 8 decreased by a number x is 8 minus x. Oh, the one I wanted to show you, 18 subtracted from a number x. Order is not implied by the English here. The order is actually the reverse, so you need to be very careful to read. Okay, you try number 9. Go ahead and pause. Okay, so this is d minus 7 because it's 7 less than d. The quotient of twice a number n and 9. That one's a little tricky. First of all, quotient implies division. Twice a number n, let's look at that. Twice a number n, that's 2 times n. And then a quotient is division. So 2n divided by 9, or you could write 2n over 9, because a fraction bar simply means divided by. Okay, 1/2 of a number x decreased by 5. Well, I like to underline the parts of the phrase that I'd like to do together first. 1/2 of a number x is 1/2 x, 1/2 multiplied by x, decreased by 5. So this is 1/2 of a number x decreased by 5. Okay, you go ahead and pause and do the you try. Okay, the cube of a number x, that is x to the 3rd power, or x cubed. 1/4 of that is 1/4 multiplied by x cubed, so it's 1/4 times x cubed. Okay, now remember when you're doing your homework to check the odds in the back as you go, because that way you make sure you're not making any mistakes as you go.